This lesson covers some of the more advanced memory and processor configurations we can make on virtual machines. I'm going to look at the properties of a virtual machine here. And under memory, there are really three primary values we configure: a startup amount of memory, a maximum amount of memory, and new to Windows Server 2012 is a minimum amount of memory. Again, these are only available if I turn on dynamic memory. What these mean is when this virtual machine starts up, it initially sees this amount of memory, the startup RAM, or 2 GB in this example. The maximum amount of RAM is the amount of memory that the VM can use up to if it needs it. And the way this works is Hyper-V is not using memory overcommit. It doesn't tell the virtual machine it has 4 GB of memory. Instead, it tells it you have 2 GB of memory. And via its integration services, it's keeping an eye on how it's using that memory. Modern operating systems don't leave any memory empty. If it sees memory, it will use it for caching. So you'll very rarely see free memory. You may see available memory, and available memory represents, for example, if I go to my VM and I look at my task manager, if I look at memory, I see available is 347 megabytes. So that memory is probably being used for caching. Notice caching is 200 megabytes. But if it needed to, it could drop that out. So it can actually use it if processes need it. So Hyper-V is constantly monitoring the amount of memory that virtual machines are using. If the available memory drops below a certain threshold, which is what I configure in this memory buffer, so if it has less than 20% in this case of its memory as available, if the memory physically exists is available in the Hyper-V host, so the hypervisor can access it, it will inject some memory into that virtual machine. And the virtual machine would see this new memory and then start using it. And it can inject up to this maximum amount, i.e. 4 GB. If the virtual machine is then no longer using the memory, if its memory demand decreases, Hyper-V can claim it back through a balloon driver. This is a kernel-level mini device driver, which means if it asks for memory, that guest operating system has to honor it and give it the memory. So Hyper-V can claim memory back. This is telling it this is the lowest amount of memory that VM is ever allowed to have. It may seem odd that you can have a minimum lower than the startup, but there are some applications, some operating systems that require a certain amount of memory to actually start up, but then don't need it afterwards. With this configuration, the VM sees this memory initially, but can then actually shrink it later on. I can modify these values while the VM is running, the minimum and maximum, and I can also change the memory buffer amount if I want to give it more or less memory. I can set its priority compared to other VMs in times of contention. There are some special cases for using dynamic memory. Some applications like SQL, Java applications, they have their own memory management, and they will just constantly take whatever memory is available. So in these cases, you either don't want to use dynamic memory, or perhaps you set this to something like 5%, because even SQL and Java will leave a certain amount of available memory. I can actually track what the VM is currently doing. If I look at the memory tab, I can see its startup was 2, its assigned memory is actually only 1140 megabytes, so it actually has taken memory back. The memory demand by the operating system is only 957. If I look again at that virtual machine, it still thinks it has 2 gigabytes. There is no way you can actually take memory away from an operating system. But again, that balloon driver inflates itself to claim the memory back. We can see that. Using RAM map from sysinternals, I can see driver locked. So this is a driver consuming a huge amount of memory, which is actually that balloon driver, which is why the OS thinks it still has 2 gigabytes, but in reality, nearly 1 gigabyte has been reclaimed by Hyper-V, which matches that value we're seeing here. Now, should the memory demand of that virtual machine go up, it would start allocating it more memory. So I'm going to fake that by using this consume.exe tool. So this is going to create processes to actually start consuming large amounts of memory. So it's now become very, very unresponsive, as these are now consuming all the available memory on the operating system. I've actually now even lost contact to it. On the Hyper-V host, we can suddenly see its assigned memory is increasing. We can see what the memory demand of that OS is, and it's actually it's injecting more memory into that operating system as it's demanding more and more. Should I then go in and stop those processes, it would be able to claim that memory back. So I've now stopped both of those processes. we'll see the memory demand has dropped right down. Straight away it's detected that's no longer there. And what we'll see over time is Hyper-V would start to claim that memory back. It will inflate that balloon driver again, which if I do a refresh, we'll see has been deflated completely. That balloon driver gave all that memory back, but we'll see that start to creep up again as Hyper-V claims the memory. So that's dynamic memory, the way it can intelligently add memory to an operating system, but only if it needs it. Now there is one special setting related to this, because you now have this scenario. What if this VM rebooted? Maybe it's only actually using a gigabyte of memory, but its startup memory was 2 gigabytes. Well, maybe there isn't an extra gigabyte available on the host. One of the new configurations in 2012 to solve this is something called smart paging. Now this feature is only used maybe for 10 or 20 seconds in those very, very small memory scenarios. If that machine did have to reboot and that extra gigabyte or that difference between the startup and the minimum was not available, or more accurately, the startup and the amount it was currently using, it would temporarily use this file to make up the amount of memory it was short. Allow the VM to start. Hopefully it would then be able to reclaim its own memory through paging, or it would just not require that memory anymore. And then that smart paging file is no longer required. So this is not an ongoing process. It's used for 10-20 seconds at most in those very, very high memory scenarios during a restart. So this is not something you ever need to touch. This is not something you need to move this to a SSD, for example. It's barely ever used, and Hyper-V will make use of it only when it has to. On the processor side, we can assign it up to 64 virtual CPUs. Now I can only set these when the VM is not running. I can reserve certain amounts of those CPUs for the virtual machine. Now by default, Hyper-V will just share out these CPU cycles throughout all of the virtual machines. There is not a direct affinity. A virtual machine is not directly tied to a specific core on the motherboard. And it's not a mapping of 1-to-1. For every virtual processor used by a virtual machine, it may actually be using the same logical processor or core as many other virtual CPUs on many other virtual machines. I could have a server, for example, with only 8 cores, and I might have 64 virtual CPUs spread over 10 different VMs. One core actually can serve many, many VMs, and that's what gives us our high utilization. So I can set a reserve for certain virtual machines to make sure they always have a certain amount. I can even limit them to say, well, I don't want you using, for example, more than 50% of the available CPUs that are assigned to you. I can set a relative weight. So the higher the weight, the more CPU cycles this gets in a time of contention. For example, if I set this to 400 and all the other VMs were 100, it would get 4 times the number of CPU cycles than others if the CPU was in demand. We have a compatibility tab. So the goal here is that if I have a cluster of Hyper-V hosts, I wish to use a live migration solution, moving VMs between any Hyper-V host. Those hosts have to be running the same processor exactly, because when the operating system starts, it does a query, and it finds out the processor it's connected to, and what the capabilities, i.e. the instruction sets that are supported by that processor. If I then moved that VM to a lower processor, well, those instruction sets wouldn't be there and the VM would just crash. So by default, you will not be able to move a VM between different generations of a processor. What this processor compatibility does is it lowers the instruction sets that are available to the VM. It sees kind of a dumbed down version. This would now allow you to move between different versions of the same processor manufacturer. So I can move between different versions of Intel processors or different versions of AMD processors. This does not allow you to move between AMD and Intel using a live migration solution. They're just too different. If you need to move between different processor vendors, you have to shut down the VM and then restart it on the new host. We also have NUMA. So this is one of those tabs you really never need to touch. But because we now have this concept of 64 virtual CPUs, there are going to be times when your virtual machines will see CPU and memory spread across multiple NUMA nodes. Hyper-V passes that NUMA topology through to the virtual machine, so those NUMA-aware applications can make the most optimal decision of resource utilization. There may be some times in very specific expert circumstances you may want to change what those NUMA nodes look like and that NUMA topology. So you can do that through here. Maybe you have some differences between nodes in a cluster, but normally you would not modify these settings. This concludes the lesson on memory and processor configuration for virtual machines.